Alright guys, in the last video you guys were asked to determine x-intercepts and y-intercepts of graphs. And there was a process that you guys went through to try to do that. And one of the things that you guys were asked to do is to factor out the quantity. First, find the y-intercept. That was the first thing we did by plugging 0 into the equation. For number 5, you got the y-intercept to be 0, 2. What you would have found in number 6 is you would have gotten it to be 1 over 0, which is undefined. That means that there is no y-intercept. And then in this one, number 7, for the y-intercept, you should have gotten it to be 0, negative 2. Because you would have gotten 8 over negative 2, which would have gotten you 0, negative 2. Now, when I look at x-intercepts, remember, we want to simplify the fraction as much as possible. So like in this case, if I were to look at, So if I were to look at what cancels, I know that these two quantities cancel. So for this x-intercept, I'm looking at x plus 2 equals 0. That's what gets you negative 2 for that one. In this case, both of these x minus 1's cancel. So you're left with 1 divided by x squared. Well, if I set 1 equal to 0, it's not true. So there is no x-intercept in this case. Number 7. We look at this and we know that the x minus 4's cancel. And so in order to find the x-intercept, we're going to look at the numerator. Remember, the denominator tells us what the asymptotes are. And then we look at 3x minus 2. We're going to set 3x minus 2 equal to 0. And you guys would get x to be 2/3. Now, we're going to put it all together. And we've done bunches, pieces, parts of 2 of these. And so you're going to see me jump ahead, jump a little quicker. Because we've already found some of these points of information. So I want to look at number 1, and we're asked to graph it. Now, we've done number 1 a couple times. We found x-intercepts, y-intercepts, vertical asymptotes, horizontal. And if there was any holes, this is what we found so far, is that the intercept was at negative 1, 0. We got a point at 0, negative 1/5, or negative 0.2. It has an it has a vertical asymptote at positive 5, okay, and then it has a horizontal asymptote at 1. We've done that a couple times and we've worked through that. Okay, so let's look at this example. All right, so far we have these points, and I just plotted the vertical asymptote and the horizontal asymptote, and I'm going to plot the points that I know for sure. So I did know negative 1, 0, and I also knew like negative 0.15. So right here, folks, I just kind of came up with a table of values, just putting it in my calculator to kind of see what the graph is doing. So I can go, well, 1, 2, 3, 4, 5, 6, 7, 8. I know that 8 is going to be at negative 8.5. So it's going to be approximately like right there. And I'm going to go a little bit. I'm going to go to negative 5, which is about here, and it's about 0.4. Okay, I'm going to go to negative 2, where it's like 0.14. Let's go to 1, and 1 is going to be at negative 0.5. And then if I keep going, like if I go to 2, it's at negative 1. If I go to 3, it's going to be negative 2. And then 4, it's going to be at negative 5. So if I look at this side right here, my curve is doing this. That's what my curve looks like on that side. Now I'm just going to repeat it on the other side. I'm going to go to 6, 7, 1, 2, 3, 4, 5, 6, 7. And then I'm going to go to 7, 4. And then if I go to 8, it's going to be at 3. So what I'm seeing on this end is that it is going towards this asymptote right here. Okay? So let's look at domain. Well, domain, I know that the domain does not include does not include positive 5, because there is a break in my graph of positive 5. If I look at my range, I know that y is not going to equal the y value asymptote, which is y equals 1. Now, end behavior. As x goes to infinity, where does my y go? Well, sometimes this y, the horizontal asymptote, is going to lead me to that. Like if I look, where is x going to? Well, this horizontal asymptote is going to 1. If I look here, all of my y values are going to be going to 1. If x is going to infinity, this is going to impact what my end behavior is, and it could also impact what my range is. X goes to negative infinity, I know that my y values are getting closer to 1 as well. Okay. All right, let's look at this next one here. Go through this one a little bit quicker. So this one, we can factor it out. We've done this one a couple times. This is what the factored form turns out to be. And these are the points that we are able to find so far. We did find that there was no holes. Okay, there were no holes in this case. So I plotted the horizontal asymptote. I also plotted x equals -2, which is your vertical asymptote. Here's my table of values that I can look at to kind of help plot it. So I do have a point at -1, 0. I got one at 0, 3/2. And if I look, I could probably look at 1. What is 1? It's 2. If I look at 3, it's 2.25. So I can see right here, this graph is curving towards y equals 3. Now if I go on the other side, I got -6, 1, 2, so that's 2, 4, 6. I'm going to go up to 3.75. And then I'm going to go to 4. And then I'm going to go to 4.5. And then I'm going to go up to 6. So if I look in this case, my graph is going up like this, looking at my table. So let's try to identify what's going on here. Domain, once again, x does not equal where your vertical asymptote, which is -2. My range, well, y is not going to equal where the horizontal asymptote is. So y does not equal 3 in this case. End behavior, as x goes to infinity. Remember, this horizontal asymptote can impact the range, and it can impact the end behavior. So as x goes to infinity, my y values are going to go to +3. As x goes to negative infinity, y is going to go to +3 as well. So let's put it all together. This last one, we haven't really seen much. We haven't actually done this one at all. So remember, the first thing that we want to do is we want to kind of factor it out. So this is what it's factored out to be. After that, we want to try to find out what our points of importance are. Usually we started off with the y-intercept. If I plug 0 into this equation, I would get 0, 0 as my y-intercept. All right, next thing that we look for is we look for holes. And remember, with holes, like that's where things cancel each other out. So in this case, x minus 1 is going to help me find a hole. So in this case, I do have a hole at 1, 0. Okay? All right, now we want to find x-intercepts. Well, x-intercepts, remember, is in the numerator. Numerator is what your x-intercepts are. So in this case, looks like I got 0, 0, because that's what makes x 0. And then I got a y-intercept at -4, 0. Okay? Vertical asymptote, well, if I look at x plus 2, this other value, this is going to help me with the vertical asymptote. This is going to help me with the x-intercepts. This helps me with the hole in the graph. Okay, so in this case, the vertical asymptote would be at x equals -2. If you look at this case, the degree of the numerator is bigger than the degree in the denominator, so there is no horizontal asymptote. So that means that there has to be an oblique asymptote, and we're just going to do some polynomial long division to try to find out what that is. So I do get x, and then I got x cubed plus 2x squared. If I subtract those, that's a 1. Sorry about that. It's a 1x. So x cubed minus x cubed is 0. 3 minus 1 is 2x squared minus 4x. So that means I'm going to have a plus 2 up here. So 2 times all this, I get 2x squared plus 2x minus 4. And if I subtract all of that, I do end up with -6x minus 4. That's my remainder, but I do have an oblique asymptote, and that oblique asymptote is going to be at x plus 2. So what I'm going to do is I'm going to take that information and I'm going to kind of plot that on my graph, okay? So I plotted y equals x plus 2. That's what my line is. I graphed my horizontal asymptote. Now, what we want to do is plot as many of these points as humanly possible. So I'm going to go to like -7. So that's 2, 3, 4, 5, 6, 7. I'm going to go down to like -4.2. 1, 2, 3, 4, -0.2. If I look at 6, I'm going to go to -3. If I go to -5, I'm going to go to like -1.67. I'm going to go to -4.0. And then I am going to go -3.3. So you can see that this oblique asymptote that I plotted, it's hugging that line, but then it's also hugging that vertical asymptote. Now we're just going to do the same on the other side. So I got -1, -3. I do have 0, 0. I got 1, 2. What happens there? That is where your hole is going to be. There's a hole at that location. So I got 2, 3. And then I got 3, 4.2. So if you look at this graph, it's kind of curving towards that right there. All right, so let's look at domain. Well, domain is x does not equal only one specific value. Well, it doesn't equal two values. It does not equal -2, and it does not equal 1. The range. Is there any gaps in my graph really overall? I'm going to actually say that this is going to be all reals. Okay? And end behavior. As x goes to infinity, where is my y values going to? In this case, it's going to infinity because as x is getting bigger, where are my y values going to? They're going to positive infinity. As x goes to negative infinity, my y values are going to be going to negative infinity as well. All right, guys. Well, hopefully this was helpful. You're going to be practicing a little bit, and I hope you guys have a grand day.